Okay, let's dive into this. You've sent over some really interesting stuff about a big challenge in advanced AI.
Right.
We're talking about these super complex problems, the kind that need more than just one AI. They need like a whole team of specialized AIs working together.
Exactly. Almost like a human expert team, but made of AI agents. Think complex science problems, logistics, huge data analysis.
A single big model often just can't cut it for those.
No, you need different agents, specialists, collaborating.
And the core issue highlighted in your sources is actually designing that team, right? How do you give each agent the right instructions, the prompts?
Yeah. And
Okay.
maybe even trickier, how do they talk to each other? What's the best way for them to connect and share information? The topology, as the paper calls it.
Which until now sounds like it's been a real headache. Very manual, kind of messy.
Oh, definitely. More art than science, really. You're trying to tweak prompts for maybe 5, 10 agents, guess the best connection map.
Mm,
It's incredibly difficult.
tiny changes could mess everything up, I guess.
Completely unpredictable effects sometimes. Very time consuming.
So, what's the potential solution here? Your sources focus on this Google AI and Cambridge framework called multi-agent system search.
That's the one.
What's the big idea behind MassS?
The core idea is to automate that whole design mess. Instead of a person manually trying to figure out the best prompts and the best connections.
MSS does it automatically.
Exactly. It's designed to search for and optimize both things, the agent prompts and the system topology at the same time, finding the best team set up systematically.
Okay, interesting. Automating the design of the AI team itself. So how does it actually do that? I saw it uses a few phases.
Yeah, it breaks the problem down. Phase one is basically about prepping the individuals. It optimizes prompts for potential agents on their own, making sure they're good at their potential job before they join the team.
Right. Build strong players first. Makes sense. Then phase two.
Phase two starts looking at the team structure. It searches for good ways the agents can connect the topology, but it's smart about it. It doesn't just try everything.
It prunes the options.
Kind of. It intelligently explores connections that seem promising and cuts out ones that analysis suggests won't work well, like finding good team layouts without endless trial and error.
Gotcha. Focus on likely winners for the structure. And phase three.
That's a final polish. It takes the best topology from phase two, the best team structure, and then fine-tunes all the agent prompts within that specific network.
Ah, so optimizing the instructions again, but now specifically for how they'll work together in that final setup.
Precisely, ensuring they match perfectly in their defined roles and connections.
Okay, that three-step logic flows well. Individuals, then structure, then synergy. But the key question, does this automated approach actually work better? Does it beat manual design? What did the test show on things like math or hotpot QA?
Well, the results were pretty striking. On the math benchmark, that's a tough test for complex reasoning.
Multi-step problems, right?
Yeah. Systems designed by MassS, especially using powerful models like Gemini 1.5 Pro, hit about 84% accuracy.
And how does that compare?
Significantly better. Other approaches, like simpler automation or just scaling up manually designed systems, were more in the 76 to 80% range.
Wow. Okay, so a noticeable jump just from smarter automated design via MassS. What about the topology part? Did finding the right connections make a difference?
This is where it got really interesting, maybe even a bit counterintuitive.
Oh.
On Hotpod QA, the system MSS designed using a DeBeat structure boosted performance by 3%. On a coding benchmark, Live Code Bench, an executor topology, added 6%. Useful gains.
Okay, so structure matters.
Yes, but here's the kicker. Some interaction patterns that people often build in manually, things like agents trying to reflect on their work or summarize past steps.
Things you'd think would help.
Exactly.
Yeah.
They actually hurt performance. On Hotpot QA, adding those seemingly smart steps made performance up to 15% worse.
No kidding. 15% worse. That's fascinating. So human intuition about how agents should collaborate can actually be wrong. Quite wrong, it seems.
It really seems that way sometimes. The automated search found what empirically worked best, even if it wasn't the obvious approach. It underlines why an automated empirical method like MassS is valuable. Guesswork can lead you astray.
And it generally outperformed other automated methods too, based on the sources.
Yes, consistently across the benchmarks they tested.
So pulling back to the big picture, what does this MassS framework really mean for you listening and for where AI development is heading?
I think it marks a really important shift. Designing these complex multi-agent systems has been this tricky, intuition-heavy craft, lots of manual effort, lots of trial and error.
Yeah.
MassS points towards making it more of a systematic engineering discipline, something you can automate.
Which could make building these powerful systems much more accessible and maybe more effective.
Potentially, yes. It's a significant step in AI getting better at designing other complex AI systems.
Okay, so let's quickly recap this deep dive then. The core takeaway from your sources is that Manas tackles the hard problem of designing multi-agent AI teams by automatically optimizing both their instructions and their connections together.
Right, the prompts and the topology.
And the research shows this leads to better performance than manual approaches, sometimes significantly better. Plus, it threw up that surprising finding that some intuitive ways we think agents should interact can actually backfire.
Yeah, that was unexpected.
All pushing this field from sort of an art towards a more automated engineering process.
It's quite a development, definitely.
Which leaves us and you with the final thought to chew on based on this material. If AI, like Manas, can start automating the design of sophisticated AI systems, taking over tasks that require deep human expertise and intuition, what does that mean for the role of human developers and human creativity in AI down the road? Something to consider as these systems get more capable of building themselves.